Today we'll be covering 9.2, which is sample spaces. The main idea of this section is to find sample spaces and probability. Well, we need to know what a sample space is first. So a sample space is a set of all possible outcomes in a probability experiment. Meaning, if we're flipping, let's say we're flipping two coins. One's going to be a nickel, one's going to be a dime. A sample space is going to be all the possible outcomes. So we could say in a table, write nickel, dime, and have our outcomes be, we'll say the nickel lands heads up, the dime lands heads up. That's one possibility. Well, the nickel could still land heads and the dime could land tails. There's another possibility. Now what if the nickel lands tails? We could have the dime land heads. Or the nickel could land tails one more time and the dime could land tails. Those are the four possible ways for our experiment to go, so that is a sample space. The other way it can be written is in a tree diagram, using our second vocab term. They're similar to look to a factor tree, but with outcomes at the end of each branch. So in this case, I could go straight for my list right here. Nickels have the option of heads or tails, and again I would include a key that says H equals heads, T equals tails. If you're using abbreviation, it's always good to have a key. So my nickel could land heads or tails. Now if my nickel landed heads, my dime could still land heads, or it could land tails, which is why I have two branches going off for my nickel. Also, from my nickel landing tails, I could also get my dime to land heads or my dime to land tails. Now this is the way I prefer to do the sample spaces, just because it is a little bit quicker, especially if we use our key. We don't have to write every word out every time. On to example 1. Taylor is buying a pizza from a pizza place. They offer thin and thick crust and toppings of sausage, pepperoni, and cheese. You're limited to only one topping on the pizza, so we need to find out how many different pizzas Taylor can order from the pizza place. We're going to do this by drawing a tree diagram of the sample space. Again, different outcomes for a pizza. So, again, we're doing sample spaces in tree diagram form. So we're going to write first, what is our options here? We have options for crust, then we have options for toppings. So what options do we have for crust? We have thin, so write thin first, and we have thick. And I like to try to space these out a little evenly, as I know my branches are going to be going to the right. Now, for toppings, what options do I have for toppings? Well, I see we have sausage, pepperoni, and cheese. So I'll do it in the same order they give it to me, just to make sure I remember them all. We have sausage, pepperoni, and cheese. You can also make abbreviations for these, just make sure you make a key. And I can also have those same three options if I had thick crust. So sausage, pepperoni, and cheese. Anyone getting hungry yet? So how many total options do I have from this pizza place? To find our total options, we're going to count our last branches on the far right. We have sausage and thick, pepperoni and thick, cheese and thick. Actually, those are all thin options. Our thick options are down here of sausage, pepperoni, and cheese. So counting those, I have 1, 2, 3, 4, 5, 6 total outcomes or options. We'll typically label them outcomes. Sometimes it might be called ways as well. So this was the tree diagram form. This is going to be what the table form would look like. And of course, this table form looks a lot nicer. However, they had to write thick 3 times and they had to write thin 3 times. Whereas we only really had to write over here. But the only difference is it's a little bit cleaner in finding out. A table is a little more truer form of a sample space because they tell you each of these is a whole list of options, right? Thin cheese, thin pepperoni, thin sausage, thick cheese, thick pepperoni, and thick sausage. However, we're just going to require the tree diagrams for homework purposes. Example 2, Michelle has the options of making an outfit from a pair of shoes, a pair of pants, and a shirt. So, we're looking at pairs of shoes, shirts, and pants. And I did it the wrong order. We want shoes, pants, and shirt. We'll do it in that order. You're not stuck with doing the order they give it to you, but it just seems to work better, so that way I'm not going to forget some reason in there the pants option. So for shoes, she has a pair of tennis shoes and sneakers. So I'll just write tennis and sneakers. Again, spacing is pretty nice because I'm going to have to split twice. For pants, she has jeans and khakis. So I'm going to have 2 branches for my tennis shoes for both jeans and khakis. I'm also going to have those options where sneakers, so I'll have to write those again, both jeans and khakis. Lastly, for shirts, I have both blue and black option, or Michelle has both blue and black option. So we've got blue and black. Blue and black. And if you ever find yourself running out of space, it's okay to go down further on the sheet. Just make sure you're not going in different directions. It's a lot harder to count how many outcomes you have in the end if you're all over the place than if you're in the same area. So right here I've got 1, 2, 3, 4, 5, 6, 7, 8. 8 different outcomes. So the next option is the game of rolling a number cube and flipping a coin has been made. Each person's turn involves rolling the number cube and flipping a coin once. Person gets 1 point for flipping heads and 1 point for rolling a number greater than 3. What is the sample space of rolling a number cube and flipping a coin? So we're going to do that first. Sample space. Then we're going to find what is the probability of getting at least 1 point. So starting off, we are rolling a number cube. So we'll do the number sign in cube. And what options are there on a number cube? A number cube is the same thing as a 6-sided dice. There are many more forms of dice than just 6-sided, so that's why we'll typically use the word number cube. So we have sides with values 1, 2, 3, 4, 5, and 6. Then flipping a coin is going to give us 2 options, right? There are heads and tails. Heads and tails. So again, H for heads, T for tails. And we've got to do a heads and tails branch for each chance of rolling a dice, right? So if we roll a 5, we could roll a heads and a tails. If we roll a 6, we could roll a heads and a tails. Flip a heads or tails. Same thing with 4, 3, 2, and 1. So now that we have our sample space, we're looking for probability of at least 1 point. So a way to read at least 1 point means greater than or equal to 1 point, right? Because at least means we have to have at least 1, but if we have more than 1, that's okay. So now that we have our sample space, let's count how many we have. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? We've got 6 pairs of 2. So we'll find out later that we can actually take our options for cube, which is 6, and the number of coin options, outcomes, are 2, heads and tail. Multiply those together and we also get 12. So that's kind of a sneak peek to a later lesson. So probability. We have 12 total, but we're looking for the number of favorable over number possible. That's from the last lesson. And we already know that there's 12 total possible because we just counted them. Now we need to find out how many points we get for each one. So I'm going to make an extra little column here called points. We're going to label these in blue. So how many points are we going to get if we flip heads and we get a point for flipping heads and a point for rolling a number greater than 3? So for 1, 2, and 3, we only have the option to get at most 1 point because we can only get points from not from our roll, but from our coin flipping heads. So we can get 1 point for heads, 0 for tails. 1 for heads, 0 for tails. 1 for heads, 0 for tails. Now, down at 4, I'm going to get 1 point for flipping my cube. So, I'm going to get 2 points for flipping heads and 1 point for tails. 2 points for head, 1 for tails, 2 for head, 1 for tails. And I'm just using tallies because if I need to add up a lot of different points based on different trees, it's a little easier to deal with that way. So now I'm just looking at all the options that don't have zeros by them. I only see 3 options with 0, so that leaves me with 9. I'll put a star by each one, then have at least 1. The first 3 are my heads if I rolled less than 1, less than 4. I didn't roll greater than 3, right? So if I roll 1 in heads, I get a point. 2 in heads, I get a point. 3 in heads, I get a point. 4, 5, and 6, no matter what happens on the coin, I'm going to get at least 1. So that's 6, 7, 8, 9. So we have 9 out of 12 ways of getting a point. And that can be simplified by dividing both the top and bottom by 3, which will give me 3/4 probability of getting at least 1 point. Next, we have John. Flip the nickel, dime, and a quarter. Nickel, dime, and a quarter. Draw a sample space to help in finding the following probabilities, and then write them in simplest form. So, again, we know our options are either heads or tails. For the nickel, once we land heads or tails, our option on the dime are both heads and tails. And lastly, on the quarter, it's heads and tails. So my sample space should look like this. Order shouldn't matter with nickel, dime, and quarter. As looking at our probabilities, we're looking at the probability that it lands 2 heads. So again, number of favorable over number possible. So how many possible outcomes do we have? Well, the nickel has 2 options, dime has 2 options, quarter has 2 options. Counting, I've got 2, 4, 6, 8. So I have 8 total. 2 times 2 is 4. 4 times 2 also equals 8. So 8 outcomes. So my number possible is going to be 8. Now how many favorable ways do I have of 2 landing heads? So exactly 2 landing heads. So going along my branch, I have heads, heads, heads. Doesn't work. That was head, heads, head. Did not work. Heads, heads, tails is exactly 2 heads. So I'll put a little dash by it. Heads, tails, heads is also 2 heads. Heads, tails, tails will not work. Tails, heads, heads will work though. You see I'm going down my branches on the far right. Tails, heads, tails. Nope, that's only 1 head. Tails, tails, heads. Only 1 head. And tails, tails, tails are all not 2 heads. So I see I've got 1, 2, 3 red markings. So probability is 3/8. That cannot simplify because 3 is a prime number. And 3 does not go evenly into 8. Probability of getting 1 heads now. And I'm going to switch my color. Again, number favorable over number possible. So, probability of getting 1 heads. So, if I rolled heads, then I got 2 more heads, that wouldn't work. Heads, heads, too many heads, not going to work. So it won't work for these 2. Heads, tails, heads, not going to work. Heads, tails, tails, 1 head, so I'll do a star by that one. That'll work. Tails, heads, heads, not going to work. Tails, heads, tails, that will work. Tails, tails, then heads, that will work as well. Tails, 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 not going to work. So I have 3 stars, out of 8 total. My number possible didn't change, so my answer is 3 out of 8. Lastly, we're doing the probability of all tails. Well, if it starts with head, it's not going to work. So we use black again. Those top 4 are not going to work because if I flip heads, I'm not going to get all tails. Tails, heads, these 2 branches aren't going to work either because I need all tails. Tails, tails, heads, not going to work, but tails, 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 my one that works. Do a circle and dot by it. So I only have 1/8 chance of flipping all tails. So that's it for this lesson. If you have any questions or any other problems you need help with, you can go to the peer tutors, and they will also assist you in more examples.